Guys, welcome to the channel. This is Sanket Jain. Today in this video we will be covering chapter number 3, that is lean system and innovation. We have already covered chapter number 1 and chapter number 2 in the series, so I'm sure that you must have gone through those videos as well. Today in this video we'll be covering lean system and innovation. The chapter is divided into two sections. One is lean system, which is the majority section of this chapter. Second portion of this chapter is related to innovation, which is a smaller chunk from this particular chapter. Let's begin with lean system. So basically lean system is going to tell you about how you can apply certain measures, certain operational models into your manufacturing system so that you can improve the productivity of your manufacturing system while also improving your quality and also stripping out your cost. So what we are trying to focus on is that we want to eliminate any kind of waste, we want to improve the productivity, we also want to improve the quality, and ultimately our cost will also get reduced under lean system. So we'll be applying certain models under this, and therefore for our syllabus point of view we will be learning certain models under lean system. In the innovation part we'll be discussing on two things. One is that if you want to create a new process, what you can apply, and if you want to redesign or re-engineer an existing process, then what can you do? Okay, let's get to lean system. Lean system, as I've already told you, is a method, and it's a proper method, very organized, that is required or that is used by the organizations so that they can minimize their waste or eliminate the waste. And their wish or their desire is to eliminate the waste, but they try to minimize it. But this is done by improving the productivity. Okay, so not just they have to sacrifice the productivity but also improve it. The existing productivity should not be lost, but in fact it should be improved in the manufacturing system. And while we are talking about the manufacturing system, it is very important to understand that this is going to deal majorly with our operational part, right? Our manufacturing, our operations part. Now, because we are dealing with the operations part, we will be applying certain models here, and these models are strategic operational measures. The word operational hence is used because it is related with the operational part. So strategic operational measures are going to be used. We are going to use them to eliminate the waste, to minimize the waste, and improve our productivity. Now, why are these operational measures strategic? So that we can keep adapting to the changes that are happening in the environment, so that an organization can be adaptable to the changes. Okay, so a lean system is an organized method to minimize waste without sacrificing productivity of the manufacturing system. We are trying to optimize the workflow so that we can increase the productivity, reduce the waste through strategic operational measures so that we can be adaptable. Alright, now lean system is telling you that there are types of waste. It has categorized the types of waste into 7 types. And I remember that through this mnemonic time word, TIMWOOD. From T we have transportation. Transportation is basically unnecessary movement of goods or products. Inventory. If you are keeping more inventory than that is required, not just of the finished goods but also of raw material or WIP, then that would also form part of your inventory. Excess inventory to have is a kind of waste because it will increase your carrying cost and will also increase the finance cost on your working capital that is blocked in your inventory. So hence inventory is also a waste. Then motion is unnecessary movement of people. Alright, here transportation was unnecessary movement of products and resources. Here motion is unnecessary movement of people. Waiting time is when a product is moving from one machine to another machine so that it can be processed further. While moving towards the second machine, if the products have to wait in the middle, that is called the waiting time. We want the waiting time to be reduced as much as possible so that our workflow is optimized. Okay. Then we have overproduction, which is that if you are producing more than what is required, you would have again the excess carrying cost. You also would have the working capital blocked in your production, and therefore it will lead to finance cost as well. So overproduction is also considered to be a waste. You don't want to have more products than what are required. Then overprocessing is using more steps than what are required to produce a certain product. So let's say, for example, if I require, let's say, 5 steps to produce a particular product. But I am using 8 steps. Then therefore, what I'm doing is I'm over processing. I'm using more steps than what is required to produce a certain product. And therefore, it is a waste. And then the last one is rework from defects. Basically, if you have produced something not as per the quality standard or not as per the specifications of the customers, then it is basically considered to be a defect. And then you would have to rework on it so as to rectify it, or maybe you would have to reproduce some product because the existing product was not as per the standards of quality as demanded by the customer. Therefore, what you have to do is you have to work again, which means that it is again a type of a waste. So the last one is rework from defects. These are the 7 types of waste that are considered under lean system. Now there are certain principles of lean system. First is that your quality should be perfect right in the first time so that there is no wastage. Then of course it is leading ultimately to waste minimization. You want to reduce it as much as you can. For this you have to continuously improve, so it focuses on continuous improvement. And then the organization has to have a flexible operational process, therefore so that it can adapt to the changing environment. Then characteristics. Certain characteristics of lean system are that it will focus on zero defects, it will focus on zero waiting time, it works on a pull processing system. We've covered that in chapter number 2 under supply chain management, so I'm sure that you must have covered it with me on in that video. If you haven't, then I'll leave the link of the video in the description box below. So the third thing is that works on a pull processing model. Then the next is continuous flow of production has to be maintained. It tries to have zero waiting time. So therefore continuous flow of production is required for having zero waiting time. So therefore these points are related. And then continuous finding ways to reduce processing time. Therefore, so that what we are trying to do is we are trying to reduce the processing time so that we can have an optimum workflow, which means that we are not going for over processing. We're trying to eliminate this kind of waste. Okay, by continuously finding ways to reduce processing time. Okay, so these are the characteristics of lean system. Try to remember the types of waste at least, and also the definition of lean system. Of course, principles and characteristics um, are something that is to be understood more than what is to be mugged up. Then coming to our first strategic operational measure, which is just in time. Now we know just in time mostly as an inventory management method, right? Where we are trying to produce or procure as much as what we require and not more than that. But JIT is a little more than that. What JIT is focusing upon is that you need to have a streamlined process. A streamlined process would mean that your operations are happening as quickly as possible so that you can deliver to your customer the product on time, on the time on which you had committed to deliver the product to the customer. So therefore, hence improving the satisfaction of the customer, and ultimately they'll be ready to pay more to your organization for these products. So just in time is not just focusing on the inventory but also streamlining the process at the same time. But what we know majorly just in time as is an inventory management method, so therefore that is an important section of understanding just in time. So what we are trying to do is we have a system with objective to produce or procure goods or components when it is required by the customer of a production and not for stocking it up. You don't want to have buffer stock because you want to reduce the carrying cost and you also want to reduce the finance on the working capital blocked, right? So it's a system whose objective is that you want to produce or procure only as much as what customer requires or as much as you have to produce, but not for stocking it up. Alright, now there are certain prerequisites of JID. Before we move to the prerequisites, I'd like to mention the fact that it will definitely reduce your material handling cost, right? One of the features of JID is that it will reduce the material handling cost, it will reduce the finance cost, it will also help you to make a little adjustment to the kind of products you are making, so you might be able to deliver a wide variety of similar products. Okay, a wide variety of similar, the word similar has to be focused upon. So there is a wide variety, but variety has to be eliminated from JIT because it does not work well with variety of goods. But if there is a variety of similar product in which there is only a slight variation, then probably that is something that is achievable very nicely under just-in-time system. So that is something that would be possible. You'd be, of course, be able to supply the product to the customer on time on which you had committed to supply. So therefore, because it will reduce the material receipt time, it will also reduce the processing time and also try to reduce the delivery time so that you can deliver it on time. And because of this, the customer will be or might be ready to pay a premium price for your product. Okay, so these are the benefits that GIT can bring you, but there are certain prerequisites that you have to understand if you are implementing GIT. First is that the demand should be stable. If the demand is not stable because you are producing on demand basis, it would be very difficult to produce as much quantity as is required. If the demand is unstable, then probably a large amount of variety or a large number of units have to be produced on a single day, and then slight lesser or comparatively very less on the next day, and that would cause unnecessary cost element to come in the production process. So demand has to be stable. Second is that less variety of goods should be produced. So again, I would repeat the point that you can produce wide variety of similar products, but not the different products. So less variety of goods, but wide variety of similar products. Again, that is also backed up by this another method called cellular manufacturing that we're going to study just after just-in-time system is done. Third is preventive maintenance. Preventive maintenance basically tells you that you keep maintaining your machines and equipments and your workers so that they do not break down. There is no breakdown. So we want to avoid any kind of breakdown so that we are able to produce as per our plan. Because if we don't do it under GIT system, we will not be able to deliver the products or goods to the customer on time. And therefore, it will lead to customer dissatisfaction, which is something that we don't want to have. Right, so preventive maintenance is going to be useful. TQM will focus on the quality aspect. We've covered this topic again in chapter number 2. So you can cover that up from the other video. Vendor reliability is very important. These 3 points go together. One thing is vendor reliability. The vendor has to be reliable in terms that the vendor will provide you with the kind of goods, as in the quality of goods that you require, and that they will deliver it on time and in the exact quantity. Okay, so what we need from vendor is that they deliver the product on time to us, not the product, the component or the resources to us on time so that we can use it for production. And we want exact quantity to be delivered to us, because if the quantity delivered is lesser than what we had required, then we will not be able to produce the amount of or the units of products that we were going to for the customer satisfaction. And if they provide us with more number of units than what was required, then we will have a buffer stock that we don't have the storage capacity for, or we don't want to store only, even if we have the capacity. So vendor reliability is very important. Second is, to ensure a good vendor reliability, you also need to have communication in place. A good communication system is required with the vendor and also internally in your organization so that the information can flow as quickly as possible. We've understood under supply chain management that it is very important for the information to flow very smoothly, right? So that is just the point here again repeated from supply chain management, that if you want that the material receipt time is reduced, your information, your demand information should flow to your supplier on real time basis so that the supplier can provide you with the certain products that you want on time. Next is, the material received should be defect free. So we don't have the time to inspect the material because we are going to straight away use it for production, because we're working on order time, we're working on per order basis under GIT, so therefore we don't have the time to inspect the material. So the material received should be defect free, otherwise once we start using the material in production and if it is defective, then your production will also be defective, which we don't want because it will lead to customer dissatisfaction. Either it will lead to customer receiving the defective product, or it will lead to a defective product identified before the delivery is made, but then in that case you would not be able to make delivery to the customer on time, ultimately leading to dissatisfaction in any case. So you need defect free material. These are the prerequisites of GIT. Next is process of GIT. So the first step is that the material from the supplier should be received by the organization at exact date, exact time, and in exact quantity. Okay, the first step is that you require the material to be delivered to your place by the supplier from the supplier's location on exact date, time, and in exact quantity. Now the delivery should happen directly on the production floor so that you can use it for immediate manufacturing. There should be no time delay. As soon as you receive the resources, you're going to utilize that for manufacturing. But what happens for this is that we try to send our engineering staff at the supplier's location to evaluate and improve supplier's process. What we are doing is, for this to happen, for receiving the units on exact date, quantity, and time, and also defect free, of course, what we require to do is we are sending our engineering staff at the supplier's location to evaluate their process and to also help them improve the process so that you can ensure that the delivery is happening on time and in exact quantity and also as per the requirement of quality. So it should be defect free. That your engineering staff is going to work upon. With this, you also want to implement or not implement but integrate an electronic data interchange system with the supplier system. Basically linking of ERPs. You are using SAP, they are also using SAP. Integrate the SAP system so that your information, your requirement information can easily flow to the customer's location as soon as you are having the requirement, so that they can accordingly work themselves on your requirement and then they can provide you the products and resources that you require on time. So have an electronic data interchange system integrated with the supply system. Now coming back to our work, we are going to shorten the setup time. Okay, before that we are going to deliver the products on the specific machine. So not just on the production floor for immediate manufacturing, we're going to go a step further to deliver the products on the specific machine on which they are going to be processed further. Okay. Now the next step is to work on the process. Finally, before the process starts, you have a setup. So you want to reduce the setup time. Now earlier what used to happen is that used to have a setup time. Definitely it was long. Therefore, it required you to incur a lot of setup cost. Okay. So let's say one time you set up, it requires a lot of time to happen. And then of course you have to incur a lot of cost for that. So setup cost is huge. Now once you have set it up, you want to produce as many quantities of units as much you want, so that your per unit setup cost is as low as possible. But now we cannot produce more than what is required. So we need to reduce the setup cost per unit, we need to reduce the setup time and the setup cost, because we cannot produce more number of units. So now our planning is going to change. We are not going to go for the long run production. We're not going to go for the long runs because we don't want to produce as many quantities as possible. We want to produce as much as required. Okay. But for this, we need to ensure that our setup cost is reduced, and therefore we are going to shorten the setup time. How can this be done? Possibly by videotaping the entire setup process to identify ways in which you can reduce the setup time. Okay, so this can be done. The next thing is that you are also going to streamline the flow of production. The material should flow from one machine to another machine until unless it is finally produced into the output product, into the final product, into the finished product, and it can be packaged then therefore further. Till then we have to have a streamlined flow of production, and for this to happen there are certain other models that are prescribed here. One is cellular manufacturing, that we have the next topic as. Cellular manufacturing tells you that you can arrange your machines into cellular form. What it means is that you can club a few machines together into one cell like structure. Let's say a box, an area. Let's say if this is the cell and this is the cell, there are three cells in an organization. This can have, let's say, two machines, this can have three machines, this can have three machines, or something like that. What you are doing is you are arranging the machine in a cell form, cell like structure, so that the movement of goods from one machine to another machine is quicker. Okay, we're going to study that further under the topic cellular manufacturing itself. The next topic that the next thing you can use here is Kanban system. Kanban system is basically a visual cue or a notification card system in which the machine, let's say the second machine that is going to receive the products or components from the first machine, is notifying the first machine that only this many quantity of this component is what I require for further production. So now the first machine is going to produce only that many quantities as is required by the second machine. Okay. So what is Kanban system? Kanban system is a notification card system in which the downstream machine notifies the upstream machine of the number of units of the components that is to be fed into the downstream machine for further production. Okay. Now we have a few formulas under Kanban system. Basically, one is Kanban size, second is Kanban number. Why is it required? Let me give you a brief about it. So let's understand that because we are implementing GID system, we are already managing our inventory based on GID system, but we also need to have a Kanban system in place. Why? Because the variation of demand is definitely going to be there. It cannot happen that your demand is absolutely constant, right? So what is going to happen is that your a slight variation in demand is going to happen. Now this can be helped us by uh, this can be looked into by using Kanban system. So Kanban system, understand now Kanban system as like a box. Okay. So earlier I told you that Kanban is a notification system. Now it is basically a notification card system, and this card also stores the data of the units, which means that the type of unit, the batch if the batch is possible, the number of units, then the value of the units, any detail that is related with the with those units is going to be stored in that notification card under Kanban. Now imagine this card to be like a box, okay, like a box which can hold certain number of units. Okay, so this card is placed over a box. I hope that you remember slightly from Inter, CA Inter. So Kanban system was first introduced or talked about there in CA Inter, but it was not discussed much in detail there. So understand it like a tag on a box, okay, which holds all the information. We're going to send this Kanban to the upstream machine so that only those many quantities can be fed into the downstream machine. Okay, understand this only, like just this. But now we talked about that Kanban was a card placed over a box. Now this box is called Kanban in our case. Okay, in our case, for our understanding, we're going to call that Kanban. Now this Kanban is going to hold certain quantity of units, right? So this is the Kanban. This is going to hold certain quantity of units, let's say X units. So this X units is basically calculated by Kanban size. Okay, so Kanban size is the number of units that are held by a Kanban. Kanban is what? Kanban is a box. For our understanding. Okay. For your understanding also, you have to keep it simple. You have to understand it like this only. Understand Kanban number as the number of boxes. Understand Kanban size as the number of units placed in one box. Got it? So, when we have to explain Kanban, what are we going to say? Kanban is a notification card system or a visual queue system from downstream machine to upstream machine to feed the parts into the downstream machine as per the requirement by the downstream machine, which got the requirement maybe from another downstream machine. Okay. But for our understanding, what are we going to do is we're going to say Kanban size is the number of units in a Kanban, and Kanban number is the number of Kanbans and the number of or the number of boxes to simplify it. What is the formula? First, let's see the formula of Kanban size. Kanban size is, which is the number of units in one Kanban or one box, is going to be consumption that we have per day or per period. If it is given per week, then per week. If it is given per day, then per day. It depends how you are using the other things. But remember, everything has to be on the same track. Okay, so let's say lead time. Lead time is basically the time that is required for you to receive the products from the supplier. Let's say that is given in days and your consumption is given in weeks. Then you either have to, then definitely you have to convert the consumption into days by dividing it by 7, of course. So you have the consumption which is given per period. You have to calculate it per day or per week, whichever the situation is. Then you have the lead time. Lead time, I've already explained you, that is the time that you are going to require for the goods or components to be delivered to your location from the supplier's location. That is lead time. So consumption multiplied by lead time multiplied by location. Now what is location? So until and unless number of locations is given in the question, you are always going to assume that there are two locations. One is your location, second is supplier's location. Okay, you're going to assume two locations. One is yours, second is supplier's. But if the question mentions that these are the number of locations, let's say 3 or 4, you're going to use what is given in the question. Okay, and next is smoothing factor. Now what is smoothing factor? So let's say I had a constant demand of 300 units every day, but suddenly one day I am having a demand of 600 units. Okay, for just for our sake of understanding, we're going to take this example that one day there is a sudden spike in demand and now the demand is 600 units only for that particular day. Okay, so definitely as per what I was doing when I was doing the calculation, my Kanban size was according to the utilization of 300 units, but one day I require 600 units, so my Kanban size has to change. No, otherwise there would be stock out situation. So to adjust this, we use the smoothing factor. So what is the formula of smoothing factor going to be? So let's say that my demand is 300 on one day, and then my constant demand is also 300. So my smoothing factor is going to be, the constant demand is going to be in the denominator, and the demand that you have for that day is going to be in the numerator. So my that day's demand is 300, my constant demand is 300, smoothing factor is going to be 1. So until unless anything is given in the question, you are going to always take the smoothing factor as 1. But in our example, we also took one day where our demand was 600. So in that case, what is going to be the smoothing factor? 600 divided by 300. So your smoothing factor is going to be 2. Okay, would you remember that? So Kanban size is consumption multiplied by lead time multiplied by location multiplied by smoothing factor. Okay, C into LT into L into SF. Alright, now what is Kanban number? As in the number of boxes or the number of Kanbans. The formula is lead time multiplied by consumption plus safety stock divided by Kanban size. Lead time multiplied by consumption plus safety stock divided by Kanban size. Okay, so Kanban size is going to come from here. Lead time we already know, consumption we already know, safety stock might be given in the question in the way that you require or the organization requires to keep the safety stock for, let's say, 3 days. So what you know is that my per day consumption is, let's say, 300 in our case. Our per day consumption was 300 and the organization requires to keep safety stock of 3 days. So our safety stock is going to be 3 multiplied by 300. Hence safety stock is going to be 900. Let's say my lead time was 2, as in it requires 2 days for me to receive the product from the supplier's location. So my consumption is 300 per day, lead time is 2 days. So 300 multiplied by 2. So 600 plus 900. 1500 is going to be my numerator for the calculation of Kanban number. Okay. And you already know the location, you already know the smoothing factor, accordingly you can get. So let's say our consumption was what, 300, lead time was 2, so 600, and location is always going to be 2 until unless anything else is given in the question. So 300 300 multiplied by 2 days multiplied by 2 locations multiplied by smoothing factor of 1. So I get 1200 as Kanban size. Now my safety stock was for 3 days, right? Remember? So 300 is my consumption per day multiplied by 2 lead time plus 300 multiplied by 3 divided by Kanban size we got as 1200. So that is going to be what? 1500 divided by 1200, right? It's coming in point decimal. So it's coming as, I think 1500 divided by 1200 is what? 5 by 4. So not 5 by 4, sorry. Yeah, it's 5 by 4. So 1.25 it comes. Definitely it cannot be in the decimal. I took the numbers randomly here. So it's coming in decimal. But otherwise, the question that you're going to receive is not going to be in decimal because you cannot have 0.25 box. You're going to have either one box or two box. So even if in the strangest of the cases, you get the Kanban number in decimal, do the upper rounding. Okay, if it is coming 1.25, you need two boxes. Okay, got it? So this becomes our uh, example for Kanban size and Kanban number. All right. Now moving on to the next step, which is we have already understood that we are required to streamline the flow of production, and we are using cellular manufacturing and Kanban. Now, based on this, we also require to train the employees to operate on multiple machines, more than one machine. Either in cellular manufacturing it is going to be required because they're going to be now so one person who's the employee or the staff is going to become the owner of a particular cell. Owner as in you can say that this guy is now the responsible person for that particular cell. Okay, we call it the cell owner. So this person would be operating on the 2 or 3 machines or 4 machines or the n number of machines that are going to be there in his cell, right? So this person is required to be trained so that this person can operate on multiple machines, not just under cellular manufacturing, but this happens also under the JIT system, because we are using cellular manufacturing along with JIT system mostly. So we are supposed to train the employees to operate on multiple machines and also to do limited maintenance. Why? Because we have a prerequisite of preventive maintenance. So who are we going to focus upon? We're going to focus upon the employees. We're going to train them so that they can do this limited maintenance and do not require the staff maintenance or the maintenance staff to come and to maintain the machines. They can do it themselves on a regular basis, right? And then we also require under JIT, we also require alteration in the accounting system. What alteration do we require? We need another system which is called the backflush accounting or backflushing system. Backflushing system, understand it very carefully, is a system in which we are passing entries right after the production is done. Till the production is happening, we are not going to pass any entry. Once the production is completed, we will pass an entry under the backflushing system. How is this entry going to be passed? Understand this. I'm not going to tell you the entry. What I'm going to tell you is how is it calculated. So because we have already completed the production, what we know is that now we know the number of units that have been produced. We also know the raw material or the components that might have been required for one particular unit out of those products based on the bill of material, and bill of material is made on the basis of the standards. Okay, so what we are doing is we are multiplying the number of units actually produced multiplied by the uh, bill of material quantities, and therefore getting the material or the components or the labor hours that we might have actually used. This has to be, of course, adjusted by the scrap, because let's be honest, there is going to be a slight difference between the actual work and the standard work. Bill of material is based on the standard numbers, so therefore you have to do the adjustments or you do the reconciliation for checking out with the scrap or any other variation, so that you can get the perfect number, and accordingly the payment is made on the basis of this to the vendor. And if there are sometimes what happens is that your number and the vendor's number might not match, so you might have to again do the reconciliation. Now the problem of this is, to the problems I already discussed with you, that it becomes a little difficult for the payment system to happen. You have to do reconciliation, ultimately can lead to more cost. But then there are certain problems like production reporting becomes difficult, because the number of products, how many have you produced and how many times have you produced, it's going to be very difficult, because if the products are being created in lower volumes, of course, because it is done on the basis of the demand, and but even despite of them being in the lower volume, the turnaround is more, which means that let's say I am producing only 5 units of a particular type of item in one day, but I might be able to produce 5 units of a lot of kinds of items in one day, right? That can happen. So therefore production reporting becomes a hassle. Second is scrap reporting. You may not be able to find out the actual scrap value or the quantity, and you might find it difficult to report the scrap to be adjusted for the figures so that you can make the payment. Third is lot tracking. If it is required by the organization to produce in lot numbers or batches and they want to maintain it, GIT and lot numbers, sorry, backflushing and lot numbers become very difficult together. So you cannot, it's very difficult to track the lot number of a particular item, because you have not entered anything while the production is completed. So when the production is completed, you might be able to completely lose the track of what the lot number is or the batch number is. And the last one is accordingly your accuracy of inventory also goes for a toss, because how much of your material or components have you dispatched for the production, or how much, because sorry, it's not dispatched from the stores, it is directly received at the shop floor, at the production floor, sorry. So definitely it is going to be delivered at the production floor, it is going to be directly used, so there is no accounting happening. You are directly using it in the manufacturing, and then the accuracy of inventory is lost, because you don't know how much of your inventory has come in, how much of it has been utilized, and when you want to order again. So that becomes another problem in backflushing system. There are certain features of JIT, as I've already discussed right at the beginning, which is that your material handling cost will reduce, your receipt time will also get reduced, your labor idle time will reduce because they will now be working on multiple of machines, and they will also do the limited maintenance if they are free. And the last one is your customer responsiveness increases. This is your GIT system. Moving on to our next strategic operational measures, which is cellular manufacturing. Let's get started with cellular manufacturing. As I've already explained, that this is organization of machines into cells. So a cell can have one or more machine, and the product will move from one machine to another machine under inside the single cell, and then from one cell to another cell if the movement has to happen for processing of a production. Now, goal. The first goal is that the product should move as quickly as possible between the cells or within the cell, in between the machines. It should move as quickly as possible. Second is wide variety of similar products can be made. And third is to make as little waste as possible. Now there are certain benefits from cellular manufacturing. First is you get more flexibility. You can do minor changes because of the automated machines to the production. So you can do wide variety of similar products. Second is you can quickly identify the problems and accordingly do the maintenance. So because every machine is now divided into cellular structure, there are certain machines in, let's say, I'm going to draw and explain this. Let's say these are three cells. Okay. You have three machines here, you have two machines here, and you have, let's say, again, three machines here. All right. Now, if the defect or if the problem is, let's say, located in this cell, because we have to just identify which of the three cells is having the problem. You have already identified the cell in which the problem is happening, and then you can just simply ask the cell owner, and the cell owner can identify very easily which machine is creating the problem. Okay, one of the three, right? So instead of checking 8, you have to check only first 3 and then 3. Okay, and this also becomes easier because the cell owner, who's the responsible person for the cell, might be able to identify this very quickly because he is the one who's operating on all the machines together inside this cell, and then your cell can also be easily identified. So therefore your problem identification becomes very easy in your cellular manufacturing structure. Okay. Then the third point is it encourages communication in between the cells, and the fourth point is reduces the inventory waste, errors, therefore lead time and space is also reduced. So these are the benefits of cellular manufacturing. Now there are three structures which have been talked about in the material that is given by ICI. They have not discussed, but they've just used the terms in one of their answers. So I'm going to quickly explain the structures. One is U-shaped, second is inverted U, third is straight line. We can understand that this is a U-shaped structure, but what is the difference between U and an inverted U? Because ultimately it's going to look like a U only, right? Because if it's this way or this way, it's still U, right? So that is not what they mean by inverted U. This is U and this is also inverted U. But how are they different is that U will have all the machines inside, and inverted U will have all the machines outside. Okay, getting the point? This is inverted U, this is U. And a straight line is simply a straight line. You can have the machines here. Okay, this is a straight line. Alright, understood? Okay. So that was U and inverted U. There are three structures that have been talked about in your material. Next is design. Now there are four designs that have been talked about and have been given a little bit of explanation about. First is single machine cell with fixtures. So this cell will have only one machine with a few fixtures and tools so that production can happen inside this cell. So the single machine is there. Second is group machine cell with manual handling. So there are more than one machine, of course, because of the group machine cell structure. It has manual handling, which means that if the product has to move from one machine to another machine, that is done by the labor. Third is group machine cell with semi-integrated handling. So a little bit of work is done by the people, which is done manually, and certain work is done by the machines. So there are of course more than one machine here because of the group machine cell structure. Second is semi-integrated handling will tell you that it will have a conveyor belt which takes the products from one machine to another machine, but then manual handling also is required. And third is flexible manufacturing system in which complete automation is there. Everything it's a group machine cell structure. It has more than machine, but it has complete automation. Okay, so no manual handling is required under flexible manufacturing system. Now, if you want to implement uh, cellular manufacturing, how to arrange the cells or how to arrange machines in cells is something that is going to be a little tricky to understand, and therefore we have one model which is called rank order clustering method as a part of our syllabus. Rank order clustering method is used to find out part families and then machine families accordingly, so that we can arrange them into a cell-like structure. Now there will be certain difficulties in creating flow, not actually difficulties, but these are certain points that you need to consider before you implement cellular manufacturing, because these might cause difficulty in creating flow. So these are certain points that you need to consider. First is if there is any exceptional element that is required to be produced that can disturb the flow of your production. Second is the distance between the machine. Third is the route that the parts are going to take. Fourth is the variation between the cell load, which means that one cell might have the capacity to produce more faster than the other cell. And if the parts have to move from this particular cell to another particular cell, then there might be waiting time involved if their load variation is high. So cell load variation has to be taken care of. Fourth is if there is a bottleneck machine, it can stop working after the required amount of time you have is over. Then machine location has to be considered, and dynamic parts demand. If the parts demand is dynamic, it will again might create a flow and difficulty. This is cellular manufacturing. Our next topic is Kaizen costing. Kaizen costing is simply telling you that just add small bit and ultimately it will turn into a large one. So you have to do is small incremental. Okay, focus on the word incremental because I've written that in red. So definitely it's very important. So you have to make small changes but incremental changes. So let's say I studied for 3 hours today. I'm going to make a small change. I'm going to study for 3 hours 15 minutes tomorrow. But day after tomorrow you have to do another small change, but you have to be incremental, which means that you cannot study again for 3 hours 15 minutes. You have to study for now 3 hours 30 minutes or so on. So you have to have small changes but incremental changes. Okay, that should be routinely applied, and you should sustain it over a long period of time so that you can get a good result. You can get significant improvement in your results. All right. Now the goal of Kaizen costing is to eliminate any kind of waste, to also reduce the cost and to reduce errors. How can you implement? First of all, value engineering is applied. This is studied in chapter number 4. Target costing is the topic under which you basically try to understand what is value analysis and what is value engineering. So let me tell you what is value engineering. Whenever you try to create a new product, what you do is you look at certain steps and you ask certain questions so that you can reduce the cost while designing the product and the process for production of that product. So initially the value engineering is done. It is done so that you can reduce the cost right at the designing stage, and then these steps are routinely applied under Kaizen costing system, so that if there is any extra cost that might not have been uncovered by the application of value engineering would be stripped out by utilization of Kaizen costing system. Okay, so what you are trying to do is you are applying initial value engineering, and then these steps are repeated routinely under Kaizen system so that extra cost can be stripped out. Certain principles of Kaizen costing. First is that you need to have gradual improvement. Okay, it's not a dramatic improvement, not a drastic change. Gradual improvements happen. Of course, there is no limit to improvement. You can improve as much as you want to. So anytime you feel that this is the maximum that I can improve, there will definitely be more ways to improve further. So there is no limit. Third is continuous improvement of standards, because we do not try to match with the standards, we try to challenge the standards under Kaizen costing system, because what we have to achieve is we have to do incremental changes. So once you achieve a standard, incremental. Okay. So continuous improvement of standards, then collective decision making, in which you involve all the workers, ask them to participate, take suggestions from them. There is collective decision making, involvement of all the employees. This increases productivity and eliminates the waste. Okay, this is the focus of Kaizen costing. Now, one more thing that I want to talk about here under Kaizen costing system is that if you are moving from a traditional system to a Kaizen costing system, you need to take note of certain points. Which is, first point is that you have to move from cost control system to cost reduction system. Second point is that you need to increase the periodicity of increase the frequency, not the periodicity. Decrease the periodicity, increase the frequency of setting standards, because of course you are continuously improving the standards. Okay, so this is the second point. The third point is that you need to involve all the workers. Moving to another point, which is another topic, which is 5S. 5S is a workplace organization method for increasing efficiency and effectiveness in the organization. What you try to do is you try to arrange everything keep everything in its order and arrange everything at its perfect right place for it. So these are the 5 steps. These are the 5S. First is sort, which is the Japanese name for it is seri. What you try to do is you evaluate whether the items are necessary or unnecessary. All the unnecessary items are, let's say, discarded or kept aside. The necessary items are arranged on the basis that what might be used more, what might be used less, or something that is used less and is available more right now. So we can accordingly segment them into different fields, different categories, and accordingly we can arrange them at a later stage. So first step is to evaluate whether it is necessary or unnecessary, or giving certain categories to them, and accordingly then we are sorting them out. Next is setting in order. The Japanese name for it is seto. Now finally, once we have sorted everything out, we are trying to now arrange it in a proper place. So we are trying to achieve the most efficient arrangement of the necessary items. So what is required more should be kept nearer to where I work, right? For example, if I require this software which helps me to record the videos very frequently, which means that I use it every day. So therefore it should be on my desktop rather than in some folder, right? Because what I'm using daily or more frequently has to be nearer to me or more accessible to me, right? Similarly, all these necessary items have to be arranged in this most accessible arrangement. Therefore, you can reduce the time that is required for you to produce or process, so that you can improve the productivity. So what you are doing is setting everything in order. Third is shine. Shining is basically that you tell your employees and create a culture of daily cleaning. What you're trying to achieve is that your workers should clean their organization or their place of work on a daily basis or a frequent basis and avoid any kind of accident. Okay, so in shining, if we clean everything daily or frequently, we can avoid accidents. We can also keep the place which is more favorable by the people to work at. Okay, third is standardize. These practices that you have developed over here, these should be standardized in some way. Okay, you need to standardize these processes so that these processes can be applied by each and every person in your organization. Okay, the Japanese word for it is shiketsu. You don't have to remember the Japanese word. I'm just mentioning them just for the sake of information. But what you have to remember is the English name. Okay, so standardize is basically shiketsu. Standardize is that you need to establish a standard practice. You need to document it so that everyone in your organization can follow the same practice. Fourth is sustain. The Japanese name for it is shizuke. So what is sustenance? Sustain is basically to monitor if you are able to work as per the standard practices and to improve on them, and also you need to train and educate your staff members and all the other people and employees in your workplace and organization so that they can work as per the standardized practices of your organization. Okay, this is to sustain. This was 5S. Moving to our next topic, which is total productive maintenance, which is called TPM. Total productive maintenance is basically to maintain and improve your machines, equipments and to keep them in the top working condition so that any breakdown or delay can be avoided. Okay, so I'm going to just repeat the definition, which is maintaining and improving the integrity of the manufacturing system by keeping all the equipments in top working condition so that you can avoid any kind of breakdown or delay, and also not just equipments but also workforce, also the people, so that we can also avoid any kind of accident. Okay, now the phases of implementation is: first you prepare, second you introduce, third you implement, and fourth you institutionalize, which means that you plan here, then finally you make the people aware about this, that you are going to implement TPM, then you finally implement it, and then you take the benefit of the results of implementation of TPM. Now there are 8 pillars with 5S. What with 5S means that if you want to implement TPM, the basic necessity is that you need to do 5S as well. So you need to implement 5S and only then you can implement TPM. So first step is to implement 5S and then you can use the TPM process. TPM has 8 pillars. First is autonomous maintenance, which is that small maintenance activity should be carried out on a frequent or a daily basis by the operator of the machine himself. Second is planned maintenance, a planned strategy for the maintenance of the machines and equipments is created, and proper planning is done, proper scheduling is done, and accordingly maintenance keeps happening. Here planned maintenance would be done by the maintenance staff, but there is one particular section under planned maintenance which is preventive maintenance. Preventive maintenance is just like autonomous maintenance, in which the operator is required to make the daily or frequent maintenance of the machine. Third is focused improvement, that is dealing with Kaizen basically, that if you want to have small changes, you can implement Kaizen here. Next is early equipment management, which is that you want to create the equipment as early as possible. Fourth is quality management. You are focusing on the quality of the products so that your customers can be satisfied. Here, customer satisfaction is kept at priority. Training and education. What you are doing is you are training the employees, very important for them to understand how they can maintain their own machines, and therefore we are providing the training and education. Office TPM is basically implementation of TPM to increase the efficiency in your office space, in the admin space. And then safety and environment is dealing with what safety precautions can we take so that we can avoid any kind of health hazards and accidents. These are 8 pillars with 5S. Then we can also quantify TPM by using this method called overall equipment effectiveness. The formula or the method for quantification of TPM is called overall equipment effectiveness. The formula for OEE is availability multiplied by performance multiplied by quality. Availability can be calculated as net operating time upon net available time. Performance can be calculated as ideal operating time upon net operating time, and quality can be calculated as ideal operating time minus lost operating time upon ideal operating time. Now, how to find out net operating time, net available time, ideal operating time, how to calculate all of these, and lost operating time. So, first of all, you are given the total available time with you. Let's say you are working in a shift of 12 hours. So how much time do you have? Definitely 12 hours, which means that you have 720 minutes. Okay. Now you might have planned for certain things which in which you are not going to work. Let's say lunch or maintenance or um, not breakdown maintenance, planned maintenance, or general breaks, small breaks, tea breaks. All of these are planned downtime. Anything that is not happening as per the plan is unplanned downtime. Okay, if you have to stop if there is a downtime because of something that you had not planned for, that is going to be considered as unplanned downtime. Let's say breakdown of machine or electricity cut off, everything that is anything like that is unplanned downtime. Okay, so total available time minus planned downtime is going to be net available time. Net available time minus unplanned downtime is going to be net operating time. Net operating time is the time for which you have actually worked, right? So net operating time, net available time. Now availability is going to be net operating time upon net available time. How to calculate ideal operating time? Ideal operating time is basically the actual production that you have done multiplied by the standard time per unit. Okay, the standard time you should have used for that particular unit multiplied by the number of units that you have actually produced. That is going to give you the ideal operating time. Okay, so you get the ideal operating time here, net operating time was calculated here. Now let's just calculate the lost operating time. Lost operating time is going to be that the number of units that you have produced, but these are defectives and cannot be used for selling, multiplied by standard time per unit. Okay, so standard time per unit multiplied by defective production. That is going to be lost operating time. So there is one way, one more way of calculating the quality ratio, which is the production, the actual production minus the defective production upon the actual production, which means that the production that you can use for selling divided by the actual production can also give you quality ratio. Okay. Now there is one more formula for OE apart from this, and you can simply check it out right here, which is going to be cancel this is also cancelled. So it is ideal operating time minus lost operating time upon net available time. One more formula for overall equipment effectiveness. All right. Now there are certain connections between TPM and TQM. TQM is something that we studied in chapter number 2. TPM we studied just now. So TPM and TQM, certain points which are connected. Both require top management commitment. Both focus on customer satisfaction. They want to reduce the cost and reduce the lead time. Both of the methods are focusing on involvement of all the workers and functions, and both the models are telling you to train the workers, and both take time to see the results. it's going to take longer time to see the results. Now there are types of TPM practices which is a part of planned maintenance. Okay, first and plus autonomous maintenance. So planned plus autonomous are the TPM practices. So one is autonomous maintenance. Planned maintenance covers planned maintenance plus preventive maintenance plus corrective maintenance plus breakdown maintenance plus maintenance prevention. Okay, so first, what is preventive maintenance? Preventive maintenance is basically small maintenance done by the operator himself. That is exactly same as autonomous maintenance, no difference. Second is corrective maintenance. Corrective maintenance is basically that you are correcting the machines, in which you are basically, what you are doing is you are analyzing the parts which are there in the machine, so that you can accordingly reassemble the parts in a certain manner with the help of the engineering staff, so that you can basically maintain the machine in a faster manner. Okay, breakdown maintenance is that if the machine is breaking down, you are not maintaining it on a proactive basis, but you are working on a reactive basis. If the machine is breaking down, you are going for maintenance, that is breakdown maintenance. Planned maintenance is basically that you have created a schedule, a proper schedule for the maintenance of your machines and equipments. Maintenance prevention is basically working with engineering staff to create a machine in certain manner which requires lesser maintenance. Okay, so what we understand basically is that if we look it from the example of cars, there are certain cars which require more maintenance, certain cars which require lesser maintenance. Okay, so that is what is being considered here. There will be certain equipments that might require lesser maintenance. Okay, so the maintenance staff is going to work with the engineering staff to create a machine or equipment like a machine or equipment which requires lesser amount of maintenance. That is maintenance prevention. These are the types of TPM practices. Sorry. Our next topic is Six Sigma. Six Sigma basically tells you that you need to practically achieve zero defects. It is only focusing on the customer satisfaction. There are two models under Six Sigma. One is DMAIC, second is DMADV. The DMAIC is define, measure, analyze, improve, control. DMADV is define, measure, analyze, design, verify. So I'm going to start with DMAIC. The define here is defining the requirement of the customers and the problems that are being faced currently in the current operations. Measure is basically quantifying these requirements and problems. Analyze is basically trying to find out the root cause behind this problem. Improve is to take corrective steps, and control is to maintain it. Simple. Now, what is DMADV? Here, define would be to define the customer requirements, and so that we can, on the basis of these requirements, create a particular type of product. Measure would be to quantify them and to find out ways in which we can achieve these requirements and satisfy these requirements of the customers. Analyze would be to select the actual kind of basically to understand this, if we come up with multiple solutions under the measure stage to satisfy a requirement which we identified in the define stage, analyzing would be to select between the multiple solutions that are available. Okay, design is to basically now work and implement and execute the solution that we have developed here in the analyze stage, and verify is to check if it is working properly or not. Okay, that is DMA-DV. Next is circumstances under which we will either apply DMAIC or DMA-DV. But before going to that, let's understand from here only, because we understood there were certain problems here and we understood that there were no problems here. We are working on the customer requirement and creating a new thing. Therefore, this works with existing process. This is working for creating a new process. Okay, so DMAIC works with an existing product or process. DMADV works with a non-existing product or process, or if the existing process has already undergone DMAIC but did not achieve results, then probably we can apply DMADV as well on that. The type of project under which DMAIC or DMADV can be applied. So if it is an ongoing continuous improvement program, your DMAIC can be applied here. If the project is of strategic importance, apply DMADV. The number of processes that can be altered under DMAIC, you can alter a single process. If you have multiple processes to alter, then you need to go for DMA-DV. Next is, if the competitor's action or the technology or the customer preference is stable, then apply DMAIC. If it is not stable, if it is changing or growing or changing, apply DMA-DV. These are the circumstances under which DMAIC or DMA-DV can be applied. Next topic was quality management tool, but now it has been eliminated from the syllabus, so we can simply eliminate this. Coming to the limitations now. The first limitation is going to be that your focus is on the qualitative part only on the quality they are focusing. Second is it does not work well with the intangible results. Third is it is complicated for certain tasks. It may also not be required for all the tasks. So all the tasks might not require to achieve the Six Sigma standard. Then substantial infrastructure investment is going to be required. Of course, you are going to do a cost benefit analysis. So the benefits that you're going to receive after the implementation of Six Sigma might outweigh the infrastructural investment that you might require initially. Of course, that way your Six Sigma implementation is going to be useful. But one of the limitations is that you are going to require to invest a lot of to make a lot of substantial infrastructure investment in the beginning. Next is real-time barriers come into play, and this can be applicable for specific type of processes only. These are the limitations of Six Sigma. Now this covers up our lean system. The second is innovation. So if you want to have a new improved process in, let's say, manufacturing system or servicing system or delivery system, then we can apply process innovation. Only that much is given for process innovation. We can apply this if we want to have a new improved process. But if we have an existing process and we want to re-engineer it, then we are going to apply business process re-engineering. So whenever a question comes from business process re-engineering, you are required to first of all start with the exact word-to-word definition of BPR. Something that you have to rote learn, mug up. Okay, so it starts with that BPR, business process re-engineering, is fundamental rethinking and radical redesigning of existing business process to achieve dramatic improvement in critical contemporary measures of performance such as cost, quality, speed and service. What is it? This fundamental rethinking, basically rethinking your exact funda. Why did you start and exactly why this way? And then radical redesigning on the basis of that of existing business process has to be existing so that you can achieve dramatic improvement. Small improvements are not welcome in BPR. If you are implementing BPR, you need to achieve dramatic improvement. For example, Ford, when applied BPR, reduced their workforce by 75%. They were able to reduce their workforce by 75%. So assume if they had, let's say, if they had 1,000 workers, by 75% reduction means that now after BPR implementation, they were working only with 250 staff members. That is a huge amount of reduction, right? So BPR works with only dramatic improvements. And this improvement is required in critical contemporary measures of performance like cost or quality or speed or service. Okay. How to implement? First of all, identify all the small processes that you undertake for under the entire system. Second is rationalization, which is identify which process is value adding, which activity or process is not value adding, eliminate the non-value adding activity. Work with the value adding ones. Now, you redesign the value adding activities and then you reassemble the value adding activities in such a manner that customer satisfaction is focused upon. So keeping the customer satisfaction in focus, you try to redesign the entire value added activity and then reassemble all of these value adding activities. Now principles have been eliminated from BPR. So this brings us to the end of the video. We have covered our chapter number 3, that is lean system and innovation. I hope you understood the chapter very nicely. If you like the content, click on the subscribe button if you haven't subscribed already. Hit the like button so that it can reach out to more and more people. Thank you so much for watching. All the best. Take care. And I'll see you next time with chapter number 4.